Our first problem here says that the demand for a particular item is given by this function right here, and we want to find the consumer surplus if this is the equilibrium point. Now, a couple things here. First of all, what is X? Well, X is the number of units that are made available to the market, and D represents the price per unit the consumers are willing to pay for those X items. So we're given here that the equilibrium point is 15,300, which means that the 15, all right, that's the number of units, now whatever they be, maybe it's 15, 1,500, 15,000, who knows, but 15 units of the product are made available to the market. And the 300, well, that's the price per unit that consumers are willing to pay. So for one of those units, a consumer is willing to pay $300 or 300 units. Now notice also that this is a quadratic. Our function is quadratic. Quadratic, right, because it's squared and the coefficient is negative. So this is a parabola that opens downward. And this is a standard shape of a demand function. I'll just draw it here. Here's X, here's the demand. Demand functions are parabolas typically that go downward, well, at least in this case. So we're asked to compute the consumer surplus at that equilibrium point, and here's the definition of consumer surplus. It's going to be the integral from 0 to the X value of the equilibrium point, which is 15 for us, the integral of this function right here. So let's take our demand function right here, subtract the equilibrium price. So let's do that here. We're going to say that the consumer surplus is the integral from 0 to X sub E, which is 15, of, now what have we got? It's going to be the demand function, and the demand function is this one up here, right? There's our demand function, so this is going to be 750 minus 2x squared, and then, all right, and then what? Well, I'm looking right here. Minus the equilibrium price, which is 300. So let's put on minus 300, and we'll integrate that with respect to X. So we've really done the work here. We've set up the integral. Now it's just a matter of computation. Let's see where this takes us. So this will be the integral from 0 to 15 of, now what do we get here? 750 minus 300 is 450 minus 2x squared with respect to X. And let's integrate it term by term, right? So we'll integrate this, so we will get, I'll do it up here. So the consumer surplus is going to be 450x minus 2x cubed over 3, right? X cubed over 3, right? We increase the exponent by 1, divide by that new exponent, and we're going from 0 to 15. So let's evaluate. So we'll put in the upper limit first. Let's do that. So, matter of fact, I'll use parentheses so we can block it off here. It's going to be 450 times 15 minus 2 times 15 cubed all over 3, and minus, now put in the lower limit. Now we've seen this before many times. I think if you put in the lower limit, which is 0, and you've got a variable in every one of those terms, the whole thing is going to come out to be 0. So I'm just going to write that 0, right? You put a 0 here, 450 times 0 is 0. Put that 0 here and compute. 0 cubed is 0, 2 times 0 is 0, divided by 3 is 0. So you just get 0 minus 0. This whole thing here is just 0. And my calculator is showing that that gives me $4,500, right? So we're going to claim now that the consumer surplus is $4,500. And should someone ask us, well, how do you know that? Well, here's our proof right here. Okay, so this is nice. We got a number. What does it mean? So here's what this means. It says when 15 units of a product are demanded. Now the 15 is coming from here, and the 300 is going to come from here. So it says this: when 15 units of a product are demanded and purchased at the equilibrium price of $300, right? So when 15 units are demanded and they're purchased at $300, the total savings to the consumer is $4,500. Now, the consumer is saving $4,500 because the consumer bought these units at $300 but was willing to pay more. Let's go all the way back up here to the top, all right? I'm going to go all the way back to the top right. There's our demand curve, right? It's a negative quadratic, so it's opening downward. Now, the equilibrium price is going to be maybe right here. That's the equilibrium price. So the consumer was willing to pay any number in any price up here, but paid actually only this one down here. So you can see that savings goes to the consumer.